All right, so let's do some conjugate acid base practice. Conjugate acid base practice. In order to recognize these, so what you're looking for in this, simply put, is going to be your hydrogen ion. So inside of that, you're not necessarily going to look for your OH ion or your hydroxide ion, but you are going to look for your hydrogen ion. So let's look at a couple. Let's look at this example. Say, for example, HF plus H2O is going to react in equilibrium with H3O plus the fluorine ion. Boom. Okay, so we have that, and we see what's happening here. Basically, hydrogen or hydrofluoric acid is donating this hydrogen to that water molecule. So in this instance, hydrofluoric acid is the acid, obviously, and then the water is the base. Okay? So we know that, but what is then, therefore, the conjugate? Now, conjugate means together, like they are in pairs, they are with each other. It's kind of like that old definition of marriage being in conjugate relationship. So what you're going to look for is you are going to look for the added or missing hydrogen atom, a hydrogen proton. So let's look over. And so the one that has the added hydrogen is going to be your conjugate acid. And then the one that is missing your hydrogen atom, hydrogen proton, is going to be your conjugate base. So what you're looking for here, and it's pretty simple, is that you're looking for your hydrogen ion. And anytime you want to, say for example, you want to write a conjugate acid or a conjugate base from a specific substance, then what you're going to do is you're going to add or take away your hydrogen, and then you are going to adjust your charge. So let's look at the carbonic acid. Let's look at carbonic acid. So let's say HCO3 negative. So what's going to be the conjugate acid of of carbonic acid? And then what's going to be the conjugate base? Now remember, if you're wanting to write a conjugate acid, simple. You add one hydrogen and you adjust your charge. So the conjugate acid, and then we're going to do the conjugate base down here. So in this case, this would be now written as H2CO3 neutral, because you had a negative charge, you added one proton, so therefore it's going to be neutral. Now, you take a second and try to write the conjugate base of this. Conjugate base. Okay, so basically you're going to take away your hydrogen, and now it's going to be CO3, but what's your charge going to be? If it was already negative and you take away another proton, now it's going to be -2. CO3 -2. So that is one way to write your conjugate acid base. So let's do another one. Let's do NH3 or ammonia. Let's do the conjugate acid and base. You can pause your video and try to write them out yourself. All right, so we're back. Remember, if you're going to write the conjugate acid, you simply add your hydrogen. So now Notice the charge is 0 on this. The charge is 0 here, 0 charge, so it's neutral. Now you're going to write the conjugate acid, conjugate base. So now you're going to do NH. We're adding a hydrogen, NH4. So now the charge is going to be plus. So you add a hydrogen, adjust your charge. Now, this is 0 again, so let's write our conjugate base. Simple, NH2, right? And if it was 0, now it has a charge of negative. Yeah, got it. Let's do a couple more, maybe 1 or 2, if that's okay with you. Let's do H. Oh, my bad. H, PO4, 2 minus. Then we're going to put our lines for our conjugate acids and bases. Conjugate acid, conjugate base. Go ahead and take a second and write those out. Remember to add your hydrogens and adjust your charge. Add your hydrogens, adjust your charge. Okay, so if we're going to write this now, we're going to write our conjugate acid like this. H2, 2, PO4. Now, what is our charge going to be? Our new charge is going to be -1 because we added a proton, right? So now let's go down here and write our conjugate base. What we're going to do, we're going to take away a hydrogen. That's going to leave us with PO4. And now, since the charge started at -2, -2 or 2 negative, our charge now is going to be -3. Yep, got it. Let's do one more. This is how you write conjugate acids, conjugate acid-base pairs. So let's do one more.